greater than x. Greatest integer not greater than x. Greatest integer not greater than x. It is denoted by like this, step x, or we can also write it as int of x. These two, step x or int of x. There are some other notations also. We will discuss all those notations. It is greatest integer not greater than x. It is denoted by step x or integral part of x. We can call it as integral part of x. Look at the notations. Integral part of x notations are these all. Look at this. Integral part of x or greatest integer function or step function or floor of x. All these are same. Look at the notation. First notation is this one. Index brackets we use. This is one notation. The other notation is it's a floor. So one more notation is this one. This is also step function. Or we write step of step x. Step of step x is finally same as step x only. Another notation is integral part of x. And one more notation is floor of x. Floor of x. These all are notations of step function. And definition is greatest integer not greater than x. So we'll work out some examples. This definition we will use and we'll work out some examples. Look at this. These are all the notations. Different ways we can denote the step function. These all are same, but most frequently we use this one. This is the most commonly used notation, step function notation. Now look at this. Let's see some examples. Some students are struggling with this step function and its properties. So look at the example here. For example, your problem is to find a step of, your problem is step of 2.789. Your problem is to find step of 2.789. So here step x definition, if you see, greatest integer not greater than x. What is your x value? X value is 2.789. So x value 2.789, if you observe, it is a real number lying between 2 and 3. So if you observe this, this is a 2 and it is a 3. So we have 2.789. Here is x. But if you look at the definition, it is greatest integer not greater than x. So not greater than x, not greater than 2.789, not greater than 2.789. What are the integers we have? Integers that are not greater than, integers that are not greater than 2.789. What are those integers? Those integers are -3, -2, -1, 0, 1, 2. Not greater, because x is here. Look at this. This is the x. X is present here. So not greater than x. We have so many integers. Among all the integers, greatest one is 2. Therefore, Step of 2.789 is nothing but 2. This is the way. Look at the another example. Another example is, suppose you want to find step of minus 1.245. You want to find step of minus 1.245. Okay. So to find step of minus 1.245, again our idea is a definition. Use your definition properly. Definition says it's the greatest integer not greater than x. Our x value is now minus 1.245. X is lying between minus 2 and minus 1. Minus 1.245 lies between minus 2 and minus 1. So somewhere we have here x. This is our x. Now not greater than x means left side. So what are integers not greater than x? Integers not greater than x. Integers not greater than x. Not greater than x. Or minus 4, minus 3, minus 2. These are all. Among all these, which is the greatest one? Among all these, greatest one is nothing but minus 2. Right? So minus 2 is only our integral part of x now. So therefore, step of minus 1.245 is nothing but minus 2. Because less than this x. Less than x, otherwise not greater than x. Not greater than x integers are minus 10, minus 9, minus 8, like this, so on up to minus 2. But among all these, greatest one is minus 2. That's why the greatest integer not greater than x is nothing but minus 2. Right? So if you want to find step function of a real number, place that real number between two successive integers. Place that real number between two successive integers. For example, look at one more question. We want to find step function of, that is, another example is to find step of minus 3.248. Right? So you have to place this x. Now our x value is minus 3.248. You have to place this between two successive integers. This is only our x. It is our x. Now we placed it between two successive integers. We placed it between two successive integers. Now one of them is here lower boundary is floor and this is a ceiling. This step function always gives floor. Therefore, step of minus 3.248 is nothing but minus 4. That's why it is, see, you see the step function. So step x is always giving integral answer. It's always giving integral part. Its answer is integral part. That's why it is also called as integral part of x. Or it's always giving floor. When you place the real number between two successive integers, it's always giving floor. That's why it is also called as floor of x. It is also named as floor of x. Or it is also named as greatest integer function. Because in the definition we stated that it is a greatest integer but not greater than x. It is a greatest integer but not greater than x. Therefore it is greatest integer function. Okay. Last example, see this. With this I hope that this definition is clear. We want to find step of 4. Integer only I gave. Step of 4 is nothing but 4 itself. Because 4 is less than or equal to 4 less than 5. Less than or equal to 4 less than 5. Look at this. Equality is satisfying here. So step of 4 is nothing but 4 only. Step of 4 is 4 itself. So consolidating all these examples and even our definition, we can generalize the definition like this now. The generalized definition is if x is any real number means it can be sometimes integer also. If x is any real number, and x is lying between n and n plus 1, x is lying between n and n plus 1. Okay, n, whereas n is integer here, positive or negative, anything. If x is any real number and x lies between n and n plus 1, but x can be equal to n, no problem, then step of x is equal to always floor. Floor means this one. So step of x is equal to n. This is the definition, mathematical definition of step function. Ordinary definition is greatest integer not greater than x. Greatest integer not greater than x. Okay. Now look at this domain. Domain of step function is, domain means input. You can give any input, no problem, that exists. So domain is all real numbers. But range, if you observe the outcomes, range, if you see, it's only integers, I, R, Z. Range is I, R, Z. That is range. So we got the domain and also the range. Next, let us see its graph. Let us see its graph now. Based on graph only, we are naming this integral part of x as step function. If you look at the graph, then you will understand. Look at this. This is y-axis. And now see the x-axis. This is x-axis. And we mark on x-axis. This is 0. Next 1, 2, 3. These are so many like this because domain is all real numbers. So infinitely many real numbers we can mark on x-axis. Even it is -1 and this is -2. Right? Now let us plot the graph. Outcomes we usually plot on y-axis. Outcomes will be taken on y-axis. So on y-axis this is 1 and this is a 2. This is 1 unit and this is 2 units. But now if you look at the real numbers between 0 and 1, if I take the real numbers between 0 and 1, for all those real numbers between 0 and 1, step 0 is 0. Step 0 is 0 itself. So we'll mark here, this is 0. And up to 0.999 when we take it, step of 0.99 when we take it, it will give us a 0 only. Step value will be 0 itself. That's why step 0 is 0 and up to 0.999. 1 is open. We are not taking 1 but close to the 1. So it is a line segment. Look at this. Right hand side open, left hand side closed. Right hand side hollow circle, left hand side closed circle. So in 0 to 1, the graph is a line segment but right side open. 1 to 2, at 1, step 1 is 1. So here is 1. Up to 2, 1.99 also if you give, its graph is like this. Right side again open. 8 to 2, it will go to 2. This is a 2 value here. This is 2. Height wise, it is 2 units. 2 to 3, it is 2 only. 2 point anything you take, step value is 2 only. So if you observe it, there is a break at integer. Look at this. We have a break at 1. I'm showing a dotted lines. Look at here. We have a break at 2. And again we will get break at 3 also. At 3, it will start at 3. Up to 3.999, it will be 3 only. Again at 4, step function gives 4, like that it will go. And negative side, if you see the negative side, 0 to -1, Any real number you give, including -1, open 0, step value will be -1. So this is -1. Look at here. This is -1. So -1 is closed here. Up to here it is open here. This is open here. Right? And -2 to -1, if you take it, -2 to -1, -2 is closed. Step -2 is -2, but close to -1. That means -1.0000 something if you give, -1.000 something if you give, step value is -2. Okay, so this is, if you look at the graph now, it looks like a staircase. That's why it is known as step function. This is its graph. Now let us see fractional part of x. So we got the definition, we got some examples, it's a domain, range, and even graph also we got. I hope that you understood up to here. Now look at the fractional part of x. Fractional part of x is denoted by, fractional part of x is denoted by this one now. This is a notation. And its definition is, fractional part of x definition is x minus step x. So in other words, you bring that step x to the LHS, step x plus fractional part of x. This is integral part. This is integral part and this is a fractional part. Both when you add, then you will get the real number x. Every real number, it will have some integral part as well as fractional part. That is only real number x. So if you want to find out fractional part of 2.789, fractional part of 2.789, it is real number 2.789 minus step of 2.789. X minus step x, no, that's why. So it is 2.789 minus step function, you got it as 2. That's why your answer is 0.789. This is the fractional part. Okay, this is one example. The other example, look at the other example. If you want fractional part of minus 1.23, if you want fractional part of minus 1.23, its a definition is x minus step of x. X minus step of x is definition. So it is minus 1.23 minus of step of that is minus 2. So its answer is 2 minus 1.23. Fractional part of minus 1.23 is nothing but now. Fractional part of minus 1.23 is equal to 2 minus 1.23. So it is nothing but 0.77. This is the fractional part of x. So in the definition itself we have fractional part outcome. Domain of fractional part of x. Domain of fractional part of x is anything. It's all real numbers domain. But range is, range of fractional part of x mean its answer is always fraction. That's why we are naming it as fractional part. Always fraction means it is close to 0, open 1. Close to 0 and open 1. This is the range. So fractional part of any integer, if you write fractional part of 2 means it is 0. Reason is fractional part of 2 is nothing but 2 minus step 2. 2 minus step 2. So it is 2 minus 2, that's why 0. This is the domain and range of fractional part of x. But if you look at the graph of fractional part of x, if you see its graph, this is the y-axis. And look at the x-axis here. Zero to 1 portion, if you take it, 0 to 1. In the previous case, I'll explain. Look at this. Fractional part of x in the previous page, x minus step x we wrote now here, fractional part of x. So based on that logic, come to the cases. In the next page, I'll show you cases. Look at the fractional part of x cases. Its definition is x minus step x. But if your x values are including 0 up to 1, what happened to this step x? The step x is 0 only now. Therefore, your fractional part outcome is just x. So y is equal to x. Y is equal to x graph, you know, it's a straight line passing through origin. But when you take x values are 1 to 2, open 1 to 2, then your x minus step x means it is x minus 1. If you take x values are 2 to 3, then your step x values are, step x value is a 2. So like this. So your fractional part outcomes are in 0 to 1, it is x graph only. In 1 to 2, it is x minus 1. In 2 to 3, it is x minus 2. Now I'll show you the graph in the previous page. Look at this. So you observe 0 to 1. 0 to 1, 1 to 2, 2 to 3. If you observe, in 0 to 1, it is x. Y is equal to x graph. We will draw like this. But it's only line segment. Up to 1 only we need to take. 1 is open. Close to 0, open 1 we have. So at 1 there is a break open here. Again, in 1 to 2 portion, it is like this. X minus 1. Graph is x minus 1. So if you give 1, x minus 1 means 1 minus 1. So it starts at 0. Look at this. It starts at 0. Again, it's parallel to the previous line segment. 8 to 2, it will be open like this. Once again, 2 to 3, if you take it, it's x minus 2. So 8 to 2, it is 0. X minus 2 means 2 minus 2, 0. Again, a line segment, same parallel line segment we get. And like this. Continuously, we are going to get like this. So the graph is repeating after a length of 1 unit. That's why it is periodic. It is periodic with periodicity 1. Right? This is the graph of the fractional part of x. Now look at the properties, useful properties. Only some properties I am discussing now. Rest of the properties we are going to study in calculus. Properties of both step function and even fractional part. With this we conclude the session. First one is step of x is x only whenever x is integer, remember that. Second, step of step x is nothing but step x only. Third one, if at all x is a real number lying between n and n plus 1, this is definition itself, where n is a integer in this, then step x is nothing but n only. Fourth one, step x cannot be greater than x. So step x always lies between a real number x and x plus 1. Here x and x plus 1 are real numbers, but step x is integer. Fifth one is step x plus step of minus x. If you observe, its value 0 whenever x is integer, its value minus 1 whenever x is not an integer. You give some examples and understand that. Whenever x is not an integer, then it is minus 1. Next, fractional part of x plus fractional part of minus x is 0 whenever x belongs to integer. It is 1 when x does not belong to integer. For all x does not belong to integers. This is the fractional part of x definition. Fractional part means its answer will be always lying between 0 and 1. Okay. Next, seventh one, remember, step of x plus y is not equal to step x plus step y in all the cases. It's not true for all xy. For all xy, it is not correct. Then how to write step of x plus y, I'll tell you, look at here. If you have x is some real number, y is some real number, x and y are real numbers, where x comma y are real numbers in this, and the fractional part of x plus fractional part of y, in case less than 1, then this property is correct. Step of x plus y is equal to step x plus step y plus 1 if at all fractional part of x plus fractional part of y is greater than or equal to 1. In this case, this is the formula. But the 10th one, see here, step of x plus integer, I stands for integer. You can write it as step x plus I. Here x is real number, but I means integer here. I is integer. Then we can write step of x plus I as step x plus I. These are the useful properties. Remaining properties we will discuss in the calculus part. For trigonometry, this is enough. Trigonometry and even for other algebra chapters point of view, this knowledge is enough now, for now.